Good day everyone, my name is Mr. Emil Viante and welcome to General Physics 1.
Our math for today is perform addition of vectors. Today's topic is graphical method of adding vectors. Last time we discussed what are vectors. These are quantities that has both magnitude and direction. We can add vectors in two ways, drawing it through the graphical method, which we will discuss today, and the other through computation or the vector component method, which we will discuss in the next video. Adding vectors through the graphical method is done by drawing each vector in one flow. Observe how the vector number 2 is placed on the tip of the vector number 1. By doing so, we result in the sum, which we call the resultant vector, or R. The resultant vector is determined by drawing from the start of the first vector up to the tip of the last vector, just like so. You might have noticed a shape of a right triangle because all of our resultant vectors form a right triangle. How about this? The ends of the two vectors are connected. How can we find the resultant vector? It's by imagining and moving one of these vectors so that we can have a flow. Let's try moving vector number 2. Let's draw it on the tip of the first vector. By doing so, makes it easier to find the resultant vector. We can do the same process for vector number 1, and yet it will still arrive at the same result. The process is the same even if we have numerous vectors, and just like before, start with the first vector and finish with the tip of the last vector. Do you see a right triangle? This right triangle will serve as your guide in finding the direction in the form of an angle theta. Let's try our first example. We're gonna draw this on our grid. We're gonna add two vectors, 4 meters east and 8 meters south, and find their resultant vector. Before we start, we're gonna represent each grid as 1 meters. Let's start placing our vectors. To measure the resultant vector's magnitude, we'll use a ruler, which is 8.9 meters. And for the direction, we're going to use the angle theta, which we find using our protractor as 63.4 degrees. But this is not complete, so we indicate south of east. I know what you're thinking. Where did I get the south of east? How did we form south of east? Looking at our angle theta, the arc can be thought of being drawn from the east, then we headed south to reach the resultant vector. That's why it's called south of east. It started from the east, then went to the south to form our angle theta, which measures 63.4 degrees. How about this? We have our two vectors and the resultant vector, and by looking at our angle theta, what is the resultant vector's direction? East of north? Correct! Now let's try another. Same thing, find its direction. South of west? Correct! Remember, we always use the right triangles and the angle theta in finding the resultant vector. Now for our last example, we're gonna add 3 vectors, 4 meters east, 5 meters north, and 8 meters west, and find the resultant vector. Before we start plotting our vectors, remember to represent each grid by 1 meter. After drawing our resultant vector, we find its magnitude to be 6.4 meters, and for the direction, let's draw our angle theta. We can't draw it like this, since our angle theta must fall only in one quadrant. So let's imagine a right triangle and draw the angle theta. Measure the angle with the protractor, we get 38.7 degrees. And for the direction, we get west of north. Now before we end, assignment time! Direction. Number 1. Draw all the given vectors for each item. Number 2. Draw the resultant vector with its angle. Number 3. Write the magnitude of the resultant vector and its direction. Watch the next video for the answer. I hope you learned something. See you in the next video. Goodbye!